Yeah, all right. Good evening, everyone. Just like last week, if you remember that we started with what introduction to Python. We were able to know what Python is all about, what are the benefits of Python, and some functions, some syntaxes, loops, and things like that. Those were the things we were able to touch last week. And during the practical class, we were able to touch on how to use your loops, how to use your, what's it called, your conditional statements, how to talk, reference your little of functions, those little functions and things like that. So I think this week I will be moving into Python itself now. And I will be doing introduction to NumPy and Pandas. This is where you begin to we are getting now into the real Python programming, and you begin to talk about NumPy and Pandas. So I said efficient Python libraries for data analysis. So you realize when people say, I'm a data analyst. I'm a data analyst. As a data scientist, we are both a data analyst. And that's why I was at a meeting yesterday and somebody was like, oh, we data analysts, we are fantastic. And I said, no, data scientists are fantastic because we can do what you can do and we can do more than what you can do. So even after we've analyzed data sets, we create what? Models to solve those insights that has been generated or that has been gotten from those data sets. So if you have a financial data set and you found out that, okay, there's fraud, we can create a system, a model that can detect fraud. So that is why we are better. I always say it, but they always argue with me. Data analysts are the best. I say data scientists are the best. Let's leave that and go on to our class this evening. All right. So what is NumPy? What is NumPy? Just with the way it is written, NumPy is also known as what? Numerical Python, which is a library for scientific computing. So don't let the terminologies get you scared. I told you, Python is just so easy. Simple English, NumPy, you can see. Numerical, we got the first three letters from numerical, and we added it to PY for Python. And that's it, Numerical Python, a library for what? Scientific computation. I said it is used for numerical computations. It supports large multidimensional arrays and matrices, and you can perform what? High-level mathematical functions on it. So you can see by my right-hand side here, you will understand what a NumPy can do. You have almost about 10 tasks here, from arithmetic operation to statistical operation to bitwise operation to copy and veining arrays to stacking to matrix operation to linear algebra to broadcasting to mathematical operations to searching, sorting, and counting. So you can see how powerful NumPy is. So all these manipulations, but when we started, I told you we could do some, carry out some mathematical operations without even calling libraries. But when you are beginning to go deeper into how to do some extensive mathematical operation, you need a library called NumPy. So if I ask you now, I think by now everybody will know that NumPy is a numerical word. It is called Numerical Python, which is a library for what? Scientific computing. All right. So we'll look at how do you install and import NumPy. How do we install NumPy? I hope everyone can see my screen very well. I hope, please just let me know at the chat box that my screen is so visible, like the way I can see it. Somebody should just quickly on the chat, just signify by giving me a yes. If you can see my screen clearly and there's nothing obstructing your view. Do I have anyone? Quickly. Okay. There's nobody that means that, yes, you can see my screen clearly. Okay, yes, we can. Thank you very much, admin. I really appreciate it. All right, I appreciate Victor. Thank you. All right, so I said there are two ways to install NumPy. You can install NumPy by using a binary or precompiled version using your pip, or you can compile it from your source code and install it. This is for advanced Python. I can compile. I can teach you a code on how to compile the source code and install it. But Python has made it so easy for you and I that we don't need to what? We don't need to compile any code from the back end. So I said the simplest way to install it on your system is using the command line pip install NumPy. Pip install NumPy. You call the operation called pip, which is a pipelining for installing what? For installing a NumPy. You'll be seeing that during our hands-on. You'll see that during our hands-on. We'll install this NumPy. We'll do some manipulations and see okay, if I call NumPy, I can call math from NumPy. I can import math. I can import square root and things like that. You will see them in action. All right. I said continuation. Afterward, you can check if NumPy is properly installed. That's one good thing about Python. After you've installed something, you have everything to be able to check how it works fine. You can check if NumPy is properly installed by starting Python and running the following line of codes. Import NumPy as np. Then we can check the version of NumPy that has been installed. So when you do np._version_, you just see it like that. So you can see that it's so fantastic. It's so fantastic that I so much love Python. It's so simple to use. Maybe you can remember all these codes, and that's why it's always good not to do copy and paste when you're programming in Python. Learn to use your answer that you know what we call muscle memory. The more of typing and writing you try to do or coding you try to do, it sticks to your fingers, just like somebody who has learned how to drive. My daughter keeps asking me, she said, how did you learn how to drive? I told her, I said, my dad, your grandpa, sent me to school, driving school at the age of 16. And I was able to drive. I was like, you can still drive. And I said, yes, it's muscle memory. Even if I don't drive for a very long time, any day I wake up and you give me a car, I can get into the car and drive. So it's just the same way with Python. All right, let's go on. Then we look at arrays in Python. You need to know this very, very well when it comes to arrays in Python. And the good thing about arrays in Python is that it has both positive index and a negative index. So you can see from this picture, if you count this element, this is 1, 2, 3, 4, 5, 6, which is an array length of 6. But you will notice that when we are counting based on in Python based on the positive index, or you call it zero based, you never start counting from 1. If you really understand from the rudiments of computing or computer, or from our early days in school when we studied computer science in primary or secondary or wherever you learned a bit of computer appreciation courses, you remember that what computer understands only zeros and 1. So for the positive index, you count from 0, which is 0, 1, 2, 3, 4, 5. But it's still an array length of 6 when you count from positive. Then when you are doing the negative, you can't use 0 because 0 is is a positive number for a machine. 0 is a positive number for a machine. So when you come to the negative index, you can see that you start with -6, -5, -4, -3, -2, -1, which also carries a length of of 6. So when you have something like this and you have an array and they ask you what are the elements, the elements of this array is EDUCBA. What is an index? An indices is one element, a single element of an array, or a single, you call it a single node, exactly, from an array, from an element of an array. That's what an indices is. So when I pick one out of this element, a complete element gives you EDUCBA, which forms the length of your array. So when I pick just one out of it, it's an indices of of that array. So just have this at the back of your mind. You see them coming into limelight when we do our hands-on, because I could just ask you to create an array of 10 numbers of 10 characters. So then it depends on how you count. So if you are giving me an array and you say 5, so I understand that what your array is saying is 0, 1, 2, 3, 4. If you count, that's 1, 2, 3, 4, 5. If I say an array of 6 characters, so it means they are giving me 1, 2, 3, 4, which starts from 0, 1, 2, 3, 4. Then I say, give me a negative array. of 6 also, you know that you're starting from -6, -5, and things like that. So please, let's just have the bar at the back of our mind. That is the way array works. So I've taken time to be able to say what NumPy arrays. I said they are sequential collection of elements of the same data type arranged linearly. Exactly. For every time you have an array, you can never see an array. Let me go back so that we understand what I'm trying to talk about. You will never see an array that has a different. You can see all these are characters. You will never find an array that has E1. No, 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 no. You will always see that, and that's what you find out here. Sorry. You go back and say what? They are sequential collection of elements of the same data type arranged linearly. I said they are fundamental data structures for storing and manipulating homogeneous data. Somebody will ask me, what are homogeneous data types? I say what? It means that all the elements in the NumPy array must be of the same data type. It's either they are integers or they are floating points or they are numbers or what? Or characters. It's as simple as that. You would never see a mixture. You never see a mixture of arrays. So let's get, anytime you see the word homogeneous data types, it means that what? You have what? An element of what? In a NumPy array that what? That carries what? The same data type. When I say heterogeneous, then you know that what? It has what? Diverse what? Diverse data types. All right. Let's go on. Okay. So look at it now. I tried explaining to us what the NumPy. So when you're looking at a NumPy array, and a NumPy array consists of what? Homogeneous what? Data. So heterogeneous, you're talking of like a Python list or Panda data frame. When you look at a Panda data frame, now you're talking of having a table which has a table that has what? Rows and columns that will include what? Both character, string, integer, and the what? And Boolean. So you look at the definition. All elements are of the same type when you talk of what? Homogeneous data. Then the elements can be of different types when you talk about an heterogeneous, and I give you an example of the Python list or a Panda frame, or a Panda data frame. Then you look at an example. You can see mp.array 1, 2, 3, 4. So if you have this array 1, 2, 3, 4, if you are counting based on my positive index, can somebody help me count? I want to see us on the chart. Please give me, I'm opening the chart now. If I have an mp.array of 1, 2, 3, 4, count for me on positive index. I want you to write positive index and give me how it's going to look like. Then write again negative index and give me what it's going to look like. In the next 1 minute, quickly, let's do that based on what I showed you. My array of 1, 2, 3, 4 in a positive index. If you are writing it for Python in positive indexing and negative indexing, please let's do that quickly. 1 minute, I'm waiting. Please let our charts be active. Quickly, can we do that? I'm waiting. I have something in store for the first person that does this. I think we have to start doing positive reinforcement so that we'll participate. It's supposed to be participatory. I'm still waiting. Nobody is helping us out. Wow. Is it that we can't see our chart or we don't understand? Quickly. Who wants to bail us out? Let me pause. All right. So back to our class. When you look at the homogeneous data, as I was telling you, when it comes to performance-wise, it's faster due to what? Uniformity. You know why? Because what? You are using all elements of the same data type. Then when you look at heterogeneous, you see that it's slower due to what? Type checking and object handling. So, you know, like this now of the same type, when you look at this same type, it's easier for the system to run through 1, 2, 3, 4 than first running through Alice. If the system is going to run through Alice, it's going to give Alice an array first. So Alice is going to start with what? 0, 1, 2, 3, 4. Then before it goes to the number it picks it, then it goes to Boolean. So you see that they're slow. The memory efficiency, NumPy arrays are always faster than what using what? A Python list or what? Panda data frame. Then you can see the use case. numerical computation. What do you use it for? Numerical computation, linear algebra, or scientific what? Calculations. Then you see what our Python is a tabular data or real world data set, which is a mixed type. Then what is the library? When you are calling the library, you call the library NumPy, but with fixed data type. Then you call the library Python what flexible with types. And I talk about mutability. I say what you have a contiguous block of memory, so it's mutable. That's why you can have the negative index and the what and the positive index. Then this is pointer to objects in what in memory. When we get to advanced, we start talking of things like OOP. I think we're talking about that also, a bit of that in intermediate class when we talk about object-oriented programming. So let's go on. Let's go on. Thank you so much for the. So please, if you feel offended, I've called you out. It's not. Please don't be offended. But we need to be sure that we are getting this because it's not enough for us to just be in class. We must be able to participate and what answer questions, please. Thank you very much. Let's go on. Okay, so how do you create a NumPy array? Like I've said, I said you can import a NumPy and create an array using what? NumPy.array, and you open the bracket. But there are times whereby you find that if you're not careful, you might be having an ambiguous kind of code. So we always call what? Import NumPy as MP. Anytime you see this import is what? Calling the library NumPy. Then we say as MP. MP means alias for NumPy. So that when I'm creating my array, I say array is equal to MP, means that I'm referencing NumPy. I could write and say import NumPy, I don't put as MP. And come here and say array equals NumPy.array. It will still work. It will still work. You will still get the same word. You still get the same this thing. Then I run this and say print open bracket ARR. So then you see, then you get your what? You get an array of 1, 2, 1, 2, 3. So we'll be seeing that in our practical class. So just remember, anytime you call the word import is what summoning the library called what NumPy. And when you put as MP, MP means what? An alias, just like myself now. My name is Oluwole. Some people choose to call me Olu. Some choose to call me Wole. So it depends on, so they're giving me the alias as easy as they want it to be for them. Like the way we say also known as. So it's also known as what? NumPy is also known as what? NP. All right, let's go on. So you can see, I wanted to break down that code element that I just gave you there when I talk about import NumPy as NP. I said this imports the NumPy library and gives it an alias name called what? NP. So using NP saves time when calling functions like np.array, just like what I've said. So it's just what we are giving it was, we're just giving it a nickname, which is shorter than typing out NUMPY. Then the AAR, somebody will ask me, why did I say AAR? It's called a variable name. Anytime you see anything that says Wole equals what? 2 plus 2 or add is equals to 3 plus 3. That add, and anytime you see anything being equals to, it's a variable name. I said it stores the output of what? The NumPy array function. So when you now have this NumPy.array, this creates a NumPy array with elements 1, 2, 3. Unlike Python list, this array supports fast and element-wise operation. Then, when we have something like this is a Python. It's a Python list. A Python list of integers that passed to what? An array to convert it into a NumPy array. So you can see that. So that's what this code block I've explained here. I just gave us a table to be able to explain what? To explain the code blocks to us. All right, let's go on. Please kindly feel free to stop me if you have any question or you drop it on the chat. Admin will notify me. So we have a lot of NumPy arrays, or how would I call it? Arrays of NumPy array operators. I said NumPy arrays have many useful methods for array operations. You have the one with what we call the array.sum. You can use it to add a what? A Python list faster. Instead of me doing A plus B plus, no. You can do what? I can do this and also what? Have what? A better what? A better addition. So all I need to do is, as I said, array.sum returns the sum of all elements. Every element there returns the sum of all these elements. So you have what? Import NumPy as MP. So I purposely now use the color code, just the way Python will do it, so you will know that this is what? This is a function that calls the library NumPy, and this is a function that gives what? NumPy an alias called what? NP. And this is your variable name. Immediately you see it's equals to. So what we are doing is that by the time we do the np.array or the sum of this array here, we can call it what? We can put the answer into what? Into array. Then you see at the bottom, you see at the bottom I say, well, print what? Print what? Array dot what? Dot sum. So immediately it does array dot sum. It picks this and it adds 1 plus 2 plus 3, which will give us what? 6. If you do that, you get 1 plus 3 is 3. 3 plus 3 is what? Is 6. Can you see that? So that is what happens anytime you call that. So you can see that we have put this function mp.array into what? Into array. So that we don't write a print mp.array, then we enter the elements that will now do dot sum. Can you see how long your code is? So that's the essence of what? A variable name. Variable name just helps you to simplify the length of, imagine us saying, okay, import NumPy as MP. Then I just say mp.array is a what? Is a 1, 2, 3, like that. So I need to now say print open bracket, mp.array open bracket, the normal block bracket 1, 2, 3, block close, then dot sum. Then now put the open. No, you have too many brackets. If you are not careful, the brackets will not close. You will get confused and miss out what? A bracket. So let's go on. Then you have what we call the array.min. It returns the min. You know what min is now? We add all the numbers together and divide by the length of those numbers. So you can see that it's so similar to your array.sum. The only difference here is that we are printing our min here. So we have how many elements that are here? We have 3. The length of our array is 3. So if we add all the lists together, 1 plus 2 is 3. 3 plus 3 is 3. If we divide by 3, our answer, by the time we say print array.min, your answer should give you what? 2. Your answer should give you what? 2. Okay, let's go on. Then you have the what you call the array.std. So you see that you can calculate your hello. Okay, I think that's a mistake. So you can also what? Calculate your standard deviation. Can you see now that we are using math to calculate? Just imagine now that some of us now who maybe we are still students now. You see that your Python, you can use your Python to calculate your standard deviation. They give you some set of numbers and they say get the standard deviation of it. Instead of you trying to run, oh no, you just open your Jupyter Lab and just create an array with those numbers immediately and use a array.std. You get your standard deviation immediately. And somebody is wondering, how did he do that? Even on your phone. For those of us, I told somebody today that you can do your programming on your phone. And she was shocked. I told her to speak to admin. We have a video that we linked that we dropped, whereby you can set up your mobile phone for you to do what we're going to be doing every Friday. If you don't have light or maybe there's no power supply in your area. So it's better. Like me, I set up my phone, I set up my laptop, I set up my tablet. So I have everything. I can work if there's no light. I can work on any platform. So please check your group. You'll see that we've dropped those links on how to install on Windows platform, on Mac OS, or Linux, and on your mobile phone, especially Android. Okay, let's move on. Okay, so now we have like a short, I just call it a short break, so that I don't want to, make our mind so with a lot of information. So is there any question as we go on before we go on? We'll go back to our NumPy arrays. You have what you call array.cumulative sum. I said it returns the cumulative sum. Who can tell me what this will print out? If we import NumPy as MP, and array is equal to this with these elements, you print the cumulative sum. Who can help us print the cumulative sum? Can somebody try? What will the cumulative sum be? Quickly. Who wants to try out? I'm waiting for an answer on the chat. Amarachi already has 5 points this evening. No? She has answered one question this evening. And there's a prize for the highest point. Okay, let's make it 1 point so that it won't be biased. Or 2 points. Okay, let's make it 2 points. So Amarachi has 2 points already. So I'm waiting. If I say cumulative sum, who can try? You don't need to unmute yourself. You just drop the answer on the chat. Quickly. Waiting. Admin, you too, you can, if you want to help out too. If they don't want the gift, admin, you can snatch the gift from them. Anybody? Wow. Nobody wants to try. Okay. Maybe we don't know what a cumulative sum is. What will it print? Okay. So I will explain to you what cumulative sum does. You know, when we talked about sum, when you talk about sum, I'm saying 1 plus 2 is equal to 1 plus 2. I'm thinking running of a total. Okay, I'm seeing a question. So let me pause. This is good. I think maybe it's network. It will add all the numbers up. Amarachi said, I think running total. I mean, it's asking me for the question. I said, what is the cumulative sum? Can somebody try the cumulative sum? So what happens in cumulative sum is that it's like you're adding a number to another number and recording what the answer gives you. And as we know that the first number is 1. So we first, when it comes to cumulative sum, the first number does not move. The first number remains 1. So we take this 1. This 1 remains on its position as number 1. So we take 1 and add to 2. It becomes 3. So this place becomes 3. So we have 1, 3. Then we add 3 to 3. So it becomes 6. So by the time we print cumulative sum, we have 1, 3, 6. So you see that cumulative sum is not like addition where we added 1 plus 2 plus 3. Cumulative sum is like we're adding a number to the next number. Then whatever we get for the next number, we add it to the next number. We record that, add it to the. So if we have like an array of 1, 2, 3, 4, 5 now, if I say what is the cumulative sum, 1 will remain. The next line will be 1 plus 2. Here will be 3. 3 plus 3. Here will be 6. So we have 1, 3, 6. 6 plus 4. Then the next place will be 10. 10 plus 5. That will be 15. 15. So that's the way cumulative sum works out. With the way we are moving today, I might need to show some of these things on Python a bit if we have that time. So Amarachi is still leading this evening with 2 points. Amarachi is still leading with 2 points. So let's go ahead. Okay. All right. Then you have what you call the array.sort. You can sort. It's just so fantastic that arrays, the way arrays just work is so fine. You can have like 10,000s of numbers or elements that are given to you, and your boss just tells you, can you sort these 10,000 data sets? I want them in ascending order or descending order, whichever way, or I just want it to be sorted so that I can look at where is the highest number. Or arrays are so good. All you just do is import your NumPy as NP, call your array, and use the array.sort. You see another way I did the array now. So it's before I was saying what? Print array.sum or something. Now I've done another kind of style. So that's one thing with Python. I just want to only call this guy so that I don't have a long code. All I did was say, put this into this, then sort this number. So and I called, instead of me going straight to say print array.sort, first, when you sort, put it into this array.sort. Then print what? Print what? The array again. So by the time you print the array, who can tell me what our answer will be when you sort this array? We have 3, 2, 5. Quickly on your chat box again, sort for me. Who is sorting? Sorting. Anybody wants to best Amarachi this evening? Who wants to best Amarachi this evening? Amarachi is leading with 2 points. All right, let's sort this array of 3, 2, 5. arrange it. Let's see. I said it sorts the array in place. Amarachi again. 4 points. Wow. Wonderful. Amarachi is on fire this evening. 2, 3, 5. Thank you. So let's go on. Let's go on. I think I'm enjoying in descending order 5, 3, 2. You still have 2 points. Don't worry, I won't give you all the points. We have 10 points for today. You want to take all the points. All right, let's go on. Thank you so much. Thank you so much. At least it's interactive. I know some of us might be having issue accessing our chats and checking but let's just try as much as possible. Let's try. All right, let's go on. Then you have what you call array.shape. This one now. It says what? It returns the dimension of the array into rows and column. Into rows and column. Can you see now? You can arrange it into rows. This is where you get like a matrix form. Your matrix. So you have an array that is mp.array. You have 2 different lists of 1, 2, 3, 4, 5, 6. Now arrange them into shape, into rows and column. As we all know, which one is the row, which one is the column? I need your response on there. Is the row horizontal, or is the row vertical, or is the column horizontal, or is the volume vertical? You know, you have a rows and column. Rows and, let me just do my hand. That's how you won't see what I'm doing. Rows and column. Can somebody tell me? Woo! That's what fantastic. Yes, people are waking up. Amarachi, somebody's at your tail. I didn't guess at your tail. She just told me 2 rows, 3 columns. So we have 4, 2. Victor, what's going on? Victor, I'm waiting for you. Victor, I'm waiting for you. Don't let the ladies win us this evening. Don't let the ladies best us this evening. All right. So you have given me the shape that we'll be having what? We'll be having 2 rows and what? And 3 columns. So row is horizontal and what? And column is a vertical. So this is good. I'm really excited. I'm excited that you guys are getting this. Yes, this is good. So let's go on. I'll leave my chat on. Okay, now we now see this now. This one, I'm going to see if anybody's going to get it. It says what? We also have an operator called what? Array.type. It returns the data type of the array element. So what data type is this? Row is horizontal, thank you. Column is vertical. So if you look at this data type, what kind of data type do we have? I think I taught us data type. Wow, Amarachi. So 6 points for Amarachi. I have 2 points left for this evening. Okay, this is good. This is good. So the array type is what? It's an integer, int. It is very, very good. Very, very good. All right, let's go on. Then you have what we call transpose. Transpose. When you use the word, you use the element transpose, I say it changes the axis of an array. In simpler terms, or in simpler terms, it flips rows and columns. So rows become columns, columns become rows. So for this number, what are we going to have? Quickly, I'm waiting. Fastest finger for the last 2 points. Fastest finger for the last 2 points. So if you transpose these, what do we get? You transpose the element, the list 1, 2, 3, and 4, 5, 6. So what do you get? If you change the rows to column and column become rows. So how many rows do we have now and how many columns? I mean that. Wonderful. Wonderful. So we have what now? That is good. That is good. So you've given me a full matrix. This is very, very, very good. So 6, 4. Okay, I will still give 1 extra point now. So now we have what? 3 rows, Abi? How many rows do we have now? We have 3 rows and what? And 2 columns, right? So that is good. Before we're having 2 rows and 3 columns. Marachi is laughing. Yes, now. So let me add extra points so that there will be if there's a tie, then we'll now do a tiebreaker. So this is good. This is good. Thank you so much, guys. I love that we are following this evening. It's making the class even much more lively and interesting. Okay, let's go on. Oh, so we are through with that area of what? Of a NumPy. We are through with NumPy. So I said summary here. NumPy is a powerful library for what? Efficient numerical computation. I said it is used in conjunction with what? When you are doing your data manipulation, that's with Panda. Your matplotlib, you're trying to plot what's it called? Oh, admin, thank you very much. You are keeping scores. I love this, admin. Thank you. So Amarachi has how many points now? 6. Aderonke has 4. Where's Victor? I think network is really affecting Victor. Sorry about that, Victor. Sorry. Then it's essential for what? Scientific computing in Python. So you can see that all these things that happen, there's no magic. And that's why we have tried as much as possible in OLD to make sure that our lectures and our practicals are what? Are realistic. So you won't just be writing codes that you don't understand what is happening behind those things. So by the time you start coding, you realize, oh, this is what we've been talking about. Oh, create an array of these, transpose an array, and things like that. All right, so now we go into the deal breaker, where our data analysis guys, where they usually argue with us. We are better than you guys. Admin, you want to say something? Okay. All right. So that we are better than you guys. But funny enough, we can do what they do also. So what is pandas? You'll have been saying pandas, pandas, pandas. It's not Kung Fu Panda. It's not that lovely chubby guy in Kung Fu Panda. We're talking about what? A tool or a library in Python, which is fast, it's powerful, it's flexible, and easy to use open source data analysis and what? Manipulation tool. You can use it to create data frames. You can use it to create what? Series object, and it's built on top of what? NumPy. When you look below here, you can see numerous things that we can do using our pandas. You can detect and fix errors to prepare your data for analysis. You can match, join, concatenate data sets from various sources. You can add and delete columns. You can slice data within data frames. You can sort, filter, and group data. You can create your pivot table and stack your data set. You can detect, remove, and replace missing values. You can read and write your data, which can be in CSV. You know, our normal Excel, CSV. Scoreboard, thank you. Thank you, admin. You can your Excel sheet, your JSON strings, your HTML. You can manage your dates and time. You can create your time series analysis. You can plot graphs from data frame with what? Your matplotlib integration. So you can see. So when somebody tells you, I can use Excel, I can use Power BI, what's the other one? After Power BI, Excel, there's one more these are data analyst guys are always shouting about this, that. You tell them, somebody was telling me, I said, all those guys, you see how many tools you guys are gathering together. I said, we will just need one tool. Our Python is enough to what? To do what you guys are doing. You know, you go to Excel, you do this, then you, thank you, SQL. We don't need that. Our Python has database. We can connect with a database from our Python, do a lot of things. Retrieve, we can create a local database, we can create an online database. Tableau, thank you. Tableau also. I can use Tableau, it's a non-code. We can use Python to do what you can do. So it's always what? It's always fantastic when we say that we can do a lot of things with Python. A friend of mine was talking to me one day, saw me and said, he was doing a manipulation. The thing was, he was using Power BI and it was giving him problem. So I told him, I said, what do you want to do, Oga? He said, they told me to plot some things. I said, yeah, give me the figures. He said, but if you plot it, I said, do you know that I can also save my what's it called? Every of my end products. I don't need it to display on my this thing. I can save them. I can save it without bothering myself at all. And I can just go there and you can pick them up and put them in your Excel sheet. He was looking at me, then I did everything for him. He was like, wow. See things I've been trying to do on Excel. He just did it in a few minutes just by writing some few codes. So that's just it. So our pandas is so wonderful. So just the same way we install our NumPy using our pip install, that's the same way we install what? Our pandas. And just the same way you check for if it is properly, okay, I didn't put that there because I didn't just want to keep repeating. The same way you check for if it is properly installed and the version is just the same way you do it with your NumPy. So let's go straight to our Panda series. When you talk about series, you are talking about a one-dimensional labeled array capable of holding any data. It can hold integers, it can hold your strings, it can hold your floats and it can hold your what? Python object. It is similar to a column in your Excel spreadsheet or a single column in your data frame. So can you see that? It is very, very similar. It's just the same thing, but it's a series, just a one-dimensional. So you call again and call your import panda. When we say import, you remember that what we are calling the library panda. And anytime we say as PD, as makes us to what? To reference an alias, to give an alias to pandas. So that anytime you want to use it in your code, you will now say data equals to this list. Then S. What is the S here, please? For the last 2 points. Who can tell me what the S stands for? When I say S is equal to pd.series data print S. Who can remember? I said it when I was explaining. When you assign something or with the data also, the one I said data variable. Oh, I mean that beat you to it. Wow, so we have admin, we have 6 now. Amarachi has 6 points. Aminat also has 6 points. So we'll look for a tiebreaker before the end of the class. This is very, very good. So admin, please, you can update our score if you are still here with us. Thank you so much, admin, for the wonderful job. So this is very, very good. So what are we doing is that we are saying this list of numbers that you have, or we have called data, or we have assigned into S, print them in a one-dimensional frame. So you'll be seeing these things when we are doing our practicals on Thursday. Please, I will encourage us, please, let's try. No, you guys have been so wonderful and fantastic. I know how it is for you to come at night. Today I was struggling. I saw when Victor came in around, I was still struggling to just try not to sleep. I had to just join. I joined at about 5 minutes to. I met Aminat in the class. So it's just, you guys have just been so good. It's not easy. Even with admin, coupled with your work, some of us are at our workplace and things like that. I appreciate every one of us. So please, let's try practical, it gives you a real life demonstration of all these things. All right. So let's look at various ways of creating a series. Thank you. We have 6 points. 6 points. All right. So let's go on.
Sorry, I can't do that.
Please hold on for me. Let me close this. Okay, thank you. So you can create a series from what we call a list. When you look at a list, this is what you call a list. When you have a list is what? Just a one-dimensional, and it contains only a kind of data type when you are talking of a list. So is it that this is 1, 2, 3, or this is 1.0, 2.0, 3.0, or this is true, false, true, excuse me, or this is what? Aminat, admin, Amarachi, Victor. So it only takes the same word, the same kind of data type. But when you are talking about a dictionary can have a mixture of both what? Or both string and what? An integer, or float and integer. Can you see what it looks like? If you are seeing what I have here, you can see that we have a mixture of that. So a dictionary, just like your dictionary now, it contains different words with different kind of meaning. Then when you can now have what I call the custom index. When you look at your custom index, you can create it. It's you. Maybe Aminat works in she's a lecturer. Then she wants to create a list for her students, her student record. So she could create a custom index on her own. So it's as simple as that. So this is created by a user. So you can call it what? A user index. So it's created by an end user index. So it's custom index created by the user himself. So these are ways of creating. So we'll be practicalizing that also on Thursday, by God's grace. All right, now we come to the place where we actually need to know, because this is what helps us now to do a lot of manipulation, which is called a pandas data frame. I said a data frame is a two-dimensional tabular data structure with labeled rows and columns, basically like your spreadsheet or or your SQL table. It is built on top of what your Panda series, where each column is a series. Do you know I told you that what when you're talking of series is what is a column? It's just a series is just a column which is one dimensional. So your Panda data frame is built on what? On your Panda series. All right. Okay, now look at us now creating a data frame using a dictionary. Can you see now? So we import our pandas. Oh, I put the output. Oh, this would have been a tiebreaker. Okay, I'll look for something to break the tie. Look for something to break the tie. So you can see that we import our pandas. We give it an alias called PD. Then we create a variable name called data, whereby we have lots of data. You can see name lessons. I use Alice, Bob, and Charlie. Then age, you can see 24, 27. Then we tell it to say convert to data frame. Can you see that I've reduced, instead of writing data frame, I told us when you're writing, always use names that you can remember. So instead of writing data frame that makes my code look so, so big, and so I just use DF for my data frame. Notice that there's a curly bracket that opened there, and there's a curly bracket that closed. Sorry, I didn't highlight that. It's in black also. So anytime you call a data, you want to create what? You want to create your dictionary. Always remember that it starts with a curly bracket. Your elements are in there. Then you close it. Then data frame equals to what? PD. What is this? This is what a panda. What PD? I said what pandas. Dot the data frame data. So we say what? This data here now. Convert it to a data frame. Then print what? The data frame. You can see what happens here. This is what the output you will get. So it creates a table that has what? Name, age, and score. So it gives them a number. That one good thing about Panda is that Panda will always create what? A serial number for every day that you are trying to, every data you are trying to create, it gives you what? It gives you a serial number. So you can see that it takes Alice is 0, and you see it starts with 0. So you can see that every rule that has to do with indexing still works in data frame. It didn't start with 1. So that the length, when you look at the length of this now, is the length of this array is 3. And it's a positive array that starts with 0, 1, 2. But when you count the element, it is what? 1, 2, 3. So that's what is happening there. We change a dictionary and change it into what? Into a data frame that looks like a table. You know that this table looks very rough. There's another command on this table that we can make this table look like a well-formatted table. The command is called display. If I don't want to use print, I'll use display. Display will create a formatted, well-formatted table. All right. Okay. So I think we are going on. So I don't think we need a short break. Unless if there's anybody that wants to take a cup of water, or you want to quickly visit the washroom, or you want to, you just want to stretch your back. Okay, let's just take 2 minutes. 2 minutes, and we'll come back. This is 8:57. We'll come back 8:59. We're running up for 9:30. So we'll come back 8:59. I also will take a cup of water. All right. So we'll have a short break. Thank you. Yeah, all right. Welcome back from our break. I hope you're able to get water. I hope you're able to stretch your legs. All right. So you'll see the difference now. If you look very well, when we're talking about creating a data frame from a list and a dictionary, can you tell me what is the difference? I think this will be our tiebreaker. When you look at, I'll go back to the data dictionary. Let's go back to the data dictionary. Can you see from the dictionary? This is what the dictionary looks like. And this is what a list looks like. Who can tell me the difference? I think this will be our tiebreaker. This is for Aminat and Amarachi. What is the difference when you look at a list and you look at what? A dictionary. Quickly. So let's do the tie break so that admin can compete our results. Then admin, I'll reach out to admin on what I want to give out as a gift. So difference between what? A list. Dictionary is key value pair. This one is well arranged. Admin, I will allow you to decide from the answer. So admin, look at the answers and you decide. All right, let's go on with the class so that it won't look as if I want to be by her. I don't want to be. So let admin do the final judgment. Okay. All right. So admin, look at what has been given and give your final score. So you can see creating what a data frame from a list. So you can see the list is arranged in what? In one dimension. You can see one. So the first list, you have the name, Alice, you have the age, 24, score. Then you have that, and it converts what? So you can see the difference between, then you can see something very unique about a list and an array. When we're referencing the list, the array, the dictionary use the curly bracket. But for the list, you can see that the list is using what? A blocker bracket. So we can use that to create our data frame. All right. So let's go on. All right. So some data frame basic operation. A basic operation. So you have what we call the df.edge. So after you've created your data frame, there are some operations that you can also use to see some things. Sorry about the weather is a bit very hot. So let's go on. So when you talk about df.edge, it's talking about what? You want to view the first 5 rows of your data frame. And this works for not just data frame also, even when you read in your data set. When you're reading a data set, you use the df.edge, you can read the first row. df.tail, you are reading the last 5 rows. Then you want to see the shape. You want to see the shape of your data set. You want to see the shape of your data frame or your data set. You have what you call the df.shape. I just want to see the column names alone. df what? Dot column. I want a summary of everything that is happening on my table. What is even the information? What's the full information of the table or the data frame that I have? You have what you call df.info. You see, I told you, Python is just so simple. Can you imagine? .info. We all know English, info is info. I say, okay, tell me your information, give me your information. You know, you are giving me your name, your date of birth and things. So summary, you want to see what's the info, what's even, you know, somebody sends you a data and tells you to do some things. You don't just run and start. You need to know, okay, what's even this data about? What's in this data set? So you can see df.info. Then you want to what? Describe. You say what? You want to check the stats for the numerical columns. Like we want to check the mean, the median, the percentile. Admin, remind me again, what other thing did we check? Your admin is a very wonderful data analyst. So when you are doing data analysis and you're having issue with exploratory data analysis, reach out to admin. Admin is wonderful. She's good at this also. So please reach out. So describe shows you the statistical summary of your thank you average. Thank you. Mode. Thank you. So it tells you the statistics on your table. Thank you so much, Amarachi. Thank you so much. All right, so you can do this. There are still other, but these are the basic ones we use so much just to be able to to check our data set to know okay what's even happening in this data set. So I said assessing this data set or data. You want to assess a data by column. You want to assess a data by column. You want to see a single column name. You use df, your block bracket, what? Name. So it comes as a series. So you see all the names. Comes as a series. Then you want to check multiple columns as a data frame. You want to call both name. You can see that we are using what? A double block bracket. These are things we'll be experimenting in our what? In our practical class. All right, let's go on. Okay, what else? Then you want to access data by row. You will use what is called a look. Look, what is look? Location. And you can use the location. You can see that you have a 0 here. You can say I'm looking for location 0. When I'm talking about location 0, it means that I'm looking for the first element. So this is by label. By labeling now. You know when you are doing by labeling, who understands by labeling? By labeling, we are talking about what? The positive and negative index. Then we want to look at the position. On what position is that labeling on. So when you use by position, you use what you call the iLock. iLock now. So when we say iLock for 0, it means that is the first position. But when we are looking for location by labeling, it means that by index, this is the first word. This is the first element by index, but first element by